SQLite forensics is a key part of any macOS investigation. But if your carving workflow leaves you with hundreds of corrupt or unidentified fragments, there could be critical evidence and weeks of additional activity sitting untouched. Don't leave these files behind. Instead, send them to Mars. The macOS Artifact Recovery Suite salvages and recovers SQLite databases, as well as plist, log, and cache data from carved files, and matches them with target artifacts from your reference system. In some cases, Mars can recover thousands more database rows and hundreds of extra days of data than exists in the original files. Here's how it works. Step 1. Run an Exemplar Scan. This creates the set of reference artifacts. The catalog contains dozens of macOS targets of forensic interest, and it's easy to add your own inside the app. Mars can scan directly from most image files, including expert witness format, as well as folders, archives, and live macOS systems. It can also mount EWF images in macOS, no outdated kernel extensions required. For each exemplar database scanned, Mars creates a detailed matching template or rubric by fingerprinting the data in each column. Step 2. Run a candidate scan. A candidate is any unclassified file you want to recover. Select a folder, and Mars will compare each candidate to the set of exemplar fingerprints. If there's a match, Mars classifies and catalogs the database. Of course, there's a lot more to data recovery and to Mars than that. So let's check out what's going on behind the scenes. Each carved, corrupt, or unclassified file is categorized by scanning for magic bytes and other signatures. Non-SQLite candidates like text logs, plists, or cache files are sent to text fingerprinting. If Mars determines the file is of forensic value, it's cataloged and routed to its destination folder. SQLite databases require special handling. Their next stop is a 4-stage recovery and vetting process called variant selection. If the original SQLite opens, has a valid schema, and contains quality data, perfect. But if corruption is detected, the recovery process begins. Mars first tries the clone technique, which can repair slightly damaged files. Next, it tries the recover method, which is a salvage operation required by truly corrupt databases. Finally, Mars can run SQLite Dissect, a data recovery tool built by the U.S. Department of Defense Cybercrime Center. But let's go back to the recover step for a second. Some databases are so corrupt that data becomes lost within the database itself. The good news is that SQLite Recover can gather this lost data. The bad news is that every single lost row ends up in one solitary table, lost and found. It has as many rows as there is lost data and as many columns as the longest row. But Mars can get a lot of this data back in place with lost and found fingerprinting. Column by column, Mars identifies data roles, not just data types. For example, these aren't just floating point numbers, they're core data timestamps. This group isn't just text, they're URLs. Mars scans for UUIDs, paths, email addresses, MAC addresses, alphanumeric keys, and much more. These form the unique arches and whorls of each fingerprint. Rows of matching fingerprints are grouped into fragments. Each fragment group is split into its own table, which Mars will attempt to match. Then, the selected variant and any lost and found data are queued for reconstruction. If the candidate can't be matched to an exemplar, it's not forgotten. Mars will group it with other matching candidates. This makes it a lot easier to check for artifacts that could still have evidentiary value. Truly unrepairable databases are byte-carved with protobuf extraction and timestamp detection for manual analysis. Finally, the files are organized cleanly into folders before running the report modules, such as Wi-Fi analytics, and biome parsing. The data comparison report shows exactly how much data you've gained beyond baseline, measured in rows and days, and includes a comprehensive zoomable timeline and activity heat map. Mars has plenty of export options too, making it easy to send it to tools such as MacApt, Apollo, Plaso, and others. package up original Exemplar files, matched candidates, or both. The combined export deduplicates and merges data. An optional database source column marks each row's origin, so you can always trace the information back to its source. And the full path option recreates the original macOS file and folder structure. Mars can also recover files without a full Exemplar scan. The free scan mode allows you to use any SQLite files you want as an Exemplar, or you can use the recovery pipeline directly to quickly salvage corrupt files. Try it on the SQLite forensic corpus to see how it works. So next time you're stuck with hundreds of corrupt SQLite files, well, now you know what to do with them. Mars is available now for macOS and Windows systems. Check out github.com/warpedwing/Mars to try it for yourself. Thanks for watching.